Hi everyone, Miss Andronica's here, and today we are looking at simultaneous equations part 2. Okay, so to eliminate one of the variables, sometimes you need to multiply one or both of the equations in order to have them equal the same value. This is very similar to what we do with fractions, for example, to get like an equivalent simultaneous equations. So let's have a look at this one. Okay, so solve the following equations simultaneously. Now, if I'm looking at them to try to cancel them out, I've got 1x there, 3x, 2y, none of them match. Okay, so this is where I need to get almost like an equivalent simultaneous equation to get them to match. So the easiest one that I can see is I'll take that x. If I multiply this entire, every term in that top equation, if I multiply it by 3, then I'm going to end up with 3x up there, which matches the one down the bottom. So I'm going to go and do that. I'm going to say x times 3 is 3x. Then positive 2y times 3 is positive 6y and 18. Now that I have that, I'm going to go put this one underneath as it is. And now I can consider, am I going to add or subtract them to cancel? Well, I have two positive 3x's there, so I know I need to subtract. Okay, so that would cancel that out. I'd end up with 6y subtract negative 4y. So you've got to be very, very careful with this, okay? If I was to write this out, it would be 6y subtract negative 4y. So I need to be very aware that I've got a double negative there because it's a positive 6. I've got a double negative, so it ends up being a positive. So be very careful. It ends up being 6y plus 4y. So 6y plus 4y gives me 10y. Okay, so just be aware of that. And then I need to make sure that that is subtracted as well, which makes negative 10. Okay, divide by 10, cancel that out. Y equals negative 1. Okay, so that's my answer for y. I'm going to leave a line. My next line of working, I'm going to substitute the value in. So I'm going to say x plus 2 times negative 1 equals 6. X 2 times negative 1 is going to be negative 2 equals 6. Okay, that's my first set of working. I keep going. Positive 2 is going to cancel that out. Positive 2. X equals 6 plus 2 is 8. Okay, so that's my next set of working, and I leave a line. Continue working down your page. Okay, continue working down your page. To do a check, I'm just going to take perhaps the one that I haven't used yet, the original, one of the original equations, and do a check. So 3 times 8, take 4 times negative 1 equals 28. I need to make sure that this is okay. So 24 plus 4, because I've got two negatives makes a positive. Does it equal 28? Yes, it does. Okay. So these are the three. So I can do a little star or I can write check. But these are the three lots of working I expect. I expect to have your conversion written out. Are you plussing or minusing? Continue down. Leave a line and then continue down. Okay? Leave a line, do your check. All of this should take a column in your book, half a column in your book. Okay? Make sure you put it all there. Okay, so having a look at just one more example there for B. If we consider these, what are we going to multiply them both by or one of them by? Okay, so you don't have to always just multiply one of them. Now, there's nothing that's going to multiply up into the other. So in this case, I need to choose one of the variables and multiply the other by. So, for example, if I focus on the y's, okay, I'm going to focus on the y's. You can focus on the x's, in this case the y's. So I'm going to, like with fractions, I'm going to multiply the top one by 2 and the bottom one by 5, okay? That's a 5. So I'm going to take whatever that coefficient is and multiply the other one by it so that they equal the same. Okay, so we're going to have 4x multiplied by 2 is 8x plus 10y equals 16. So let's say that's the first equation. Let's take the second equation, okay, and multiply it all by 5. So 15x subtract 10y, 30. Okay, so see what this has done, okay? I've taken the 5 and multiplied it by 2 and taken the 2 and multiplied it by 5. But I have to do that for every single term in the simultaneous equation. So here now I can make the decision. Am I going to add or subtract from this point? So because I have a positive and a negative, if I add them, that means that I'm going to get back to 0. If I subtract, then it's going to be 10 subtract, which becomes a positive. So I know that adding is my option here. So I'm going to bring them all together. So this becomes 23x. These two cancel out, and the remainder becomes 46 divided by 23, because I need to cancel out this 23. X equals 2. I went straight to the answer. So that's my first level of working. Now, when I go to do this next step of substitution, this is where I really need to be clear. Don't use the ones that you converted. Use the original question, okay? Because if you maybe made a mistake, then it'll come out here. So I'm going to use the original question. So I'm going to take it back to 4x plus 5y equals 8. Substitute it in. So 4 times 2 plus 5y equals 8. 8 plus 5y equals 8. So if I subtract that 8, 5y equals 0. Well, if I divide, it's still going to equal 0. So y equals 0. Now, of course, I need to do my check. Again, I go back to one of the originals. I often just use the one that I haven't used yet, just in case. Okay, so that's the one I haven't used, the second one. Substitute it in. 3 times 2, take away 2 times 0 equals 6. Okay, well that cancels that out, so it ends up becoming 6 equals 6. And I know I'm correct. Okay, so your steps for solving simultaneous equations. I've just simply added one extra step here in this pinky color. Choose which variable is the easiest to cancel and multiply or divide all terms in one or both of those equations in order to for that chosen variable to be of the same value, and then to ultimately add or subtract to cancel it. Okay, then solve, then substitute, then check. These are your steps. Please don't skip one. Please don't rush through them. You need to have your workings there. Please practice them. Okay, give it a go.